Well, for the last problem, we have to graph f of x equals x to the fourth minus 4x cubed plus 10. And in that graph, we have to include the coordinates of any local and absolute extreme points and inflection points. So let's get started. We know what f of x is. Let's graph f prime of x, or at least, let's compute x prime of x. And what we get is a 4x cubed minus 12x squared. Now, let's factor out a 4x squared. And what we have is x minus 3. So setting f of x equal to 0, we would have critical points at x equals 0 and 3. Now let's graph that derivative on a line and sign that graph. So we've got a critical point at 0 and we've got a critical point at 3. So let's sign this graph. If x is less than, by the way, this will always be positive except for at x equals 0, this factor here. So let's let x be negative 1. This will be positive, but this will be negative, so the product of two unlike signs is negative. Now let's pick a point in this interval, go through the same process. How about 1? This will be positive. Again, this will be negative. The product of two unlike signs is negative. And if we go beyond 3, this will be positive, that will be positive, so our sign will be positive. So that means we're decreasing on this interval, decreasing on this interval, increasing on this. Next step, let's find the second derivative. And that equals, and let's see, 12x squared minus 24 x. And we can factor 12x out of each term, 12x. And what we get is x minus 2 in parentheses. So now our inflection points, since setting this second derivative equal to 0, our inflection points occur at x equals 0 and 2. And let's graph this second derivative. So we're going to have a 0 at 0, another 0 at 2, and now let's sign this graph. So if x is, say, negative 1, this will be negative, this will be negative, the product of two negatives is positive. What if x is 1, which is in this interval? This will be positive, this will be negative. The product of two unlike signs is negative. And finally, if x is greater than 2, we're going to have a positive product. So this tells us we're concave up on this interval, negative infinity to 0. We're concave down on the interval 0 to 2, and concave up on the interval 2 to infinity. Now, let's make a little chart and determine what these points are. And so we're looking at 0, 2, and there'll be an inflection point at each of these, and also 3. And so when x is 0, we get a 10. Evaluating f for 2, putting 2 in for x, we get a negative 6. And if you evaluate f of 3, you'll wind up with a negative 17. So let's graph this function. is x and y. And here we are at 0, 10. Let's go over to, let's see, we'll call this 3, this 2, so we'll go over 2 and down to 2, negative 6. And we'll go over 3, and we'll be down to 3, negative 17. So we're concave up, coming into 0, 10. Now we have an inflection point here. We also have, for just a moment, this tangent line will be flat. And that's why we've got we also have a critical point at 0. And then it's going to turn concave down because this is an inflection point, because our second derivative yields a 0 there when evaluated for 0. And so we're going to go down and there. Now we're going to have an inflection point at 2 because the second derivative is 0 at 2. And finally, once we we hit 3, then we're going to head back up. And why do we know that? Because the derivative, the rate of change, is positive to the right of 3, negative to the left of 3. Concavity, we're concave down to the left of 2, we're concave up to the right of 2. So our inflection points are at 2, negative 6, and 0, 10. Our min occurs, and this is an absolute min, at 3, and it is negative 17. This is also a local min because it's contained in an open interval. And there's our graph. We're done.